Simply connect.
So strategy-wise, our goal is to deliver what we call smart data storage, and that means we want to help people build a software-defined platform that can scale and uses software to be able to grow on demand, be able to add nodes on demand, be able to deal with any failures, and be as seamless as possible. The second we look at is smart storage operations. As you start growing, it's your first filer, your 10th filer, your 100th filer. At NetApp, that used to be a very classic statement of the complexity just blossoms and it becomes impossible to manage. And for us, we think operations need to change. It means we need to change the way that we manage durability within a cluster, durability of data and how we manage availability and continuous availability. We need to automate all of that. And then we need to change it in terms of the operations. So when Vikram comes up, you'll actually see what we've done to change the game in terms of operational management of large-scale systems. And then the other is analytics. So moving data to the analytics is something that is broken. It clearly doesn't work. I used to be at Oracle, and Oracle there was a huge effort to do ETL transforms of data, to load it into a different data warehouse, to try to do structured analysis. It is not the approach for petabyte scale. You've got to actually bring analytics into the platform. And you'll see what we do in terms of smart data and adding intelligence and adding understanding to the data. And then making it very easy to find and retrieve and search and really understand the objects that are in the system. So with that, what is Hyperstore? Scale-out system, we use standard commodity servers. On top of that, we wrap our software-defined storage. So we basically take control of all of the disks on top. We protect data using replication or erasure coding. And uniquely, I think to us, we can actually combine the two. So you can actually use combinations. We can manage multi-data center. You can do replications across multi-data center and then erasure coding within the data center. You can do just a widespread erasure coding for efficient backup. We have built-in compression. We actually don't mention encryption, but server-side compression and encryption are built into the platform. Actually, on the compression algorithm, you can choose the type of compression algorithm that you want to use based on the type of data that you're storing. And then, very simple to manage. You're going to see what we've done in terms of a simple UI, simple interface, but doing things like rolling upgrades, never any downtime. We want to see storage that really lasts forever. This storage, it's very difficult to build petabyte scale storage. You don't want to have to take every 3 or 4 years and go through some migration and upgrade. You've got to have a system that can scale and grow with your needs, but also one that as you obsolete older equipment and bring on newer equipment, it's able to dynamically readjust itself, rebalance itself, redistribute its data and its I/O. And then hybrid. Mike mentioned that was one of the core tenets of what we believed when we started the company overall, that you must have a hybrid storage platform. That means to us both the interface on the front end. Let's make it so that your same applications can run in the cloud as they can in your data. The exact same S3 service application. But also built-in tiering capability. So we actually have lifecycle policies built into what we call a bucket, just like Amazon would call a bucket. You're able to actually set lifecycle policies and tiering policies for moving data up to the cloud.
So when you say hybrid, you're talking about private cloud, public cloud, Glacier kind of things.
Exactly. Private cloud, public cloud, and Glacier.
Disk and flash or anything like that.
Yeah, it's hybrid for us is actually hybrid to the cloud. And the key for us is how do you make that very easy so that when you move data up to the cloud, you still have control of the namespace and the objects. You know what's moved up there. You also can have those things encrypted so that you've got the keys and credentials to them. But you get one namespace that views everything that's in your data center and in the public cloud. So, you set the tiering policy based on your application or your bucket. That's how you set the tiering policy and the archiving policy. So, what's unique? What's the secret sauce within it? Native S3 we mentioned. Truly peer-to-peer. You're going to see this from Gary, but every node has all of the services running on it. We don't have a name node interfacing to a caching node, interfacing then to to a data node. This is a peer-to-peer system where every one of them can act as the full service. And this means that, and in our performance benchmarks, we see the same thing. As you scale a node, you're scaling your capacity, but you're scaling your I/O capability. So this thing scales in a peer-to-peer manner as well. We use Casandra under the covers. Gary will show you a little more in the architecture, but that's key to us. We use that for our distribution of metadata and how we manage where objects are, how we locate objects, some of the attributes of the objects in terms of compliance to data center, compliance to locality. And multi-tenancy. I won't touch the bottom side of this, but the multi-tenancy side of things, you'll see that demoed later on. It's very important that this acts like a cloud service. Whether you're a service provider implementing this or whether you're enterprises, and we've customers who are enterprises and service providers, they want to have a multi-tenanted interface so that you can have many applications run against this. You've got the accounting, you've got the chargeback, you've got the ability to do quality of service, to control the level of service that everybody gets and make sure that you've got fairness across the environment. So simplicity at scale, this is a quick kind of dashboard views. You're going to get a demo later anyhow. But this is a view of a multi-data center deployment. Actually, this is a New York data center, Paris data center. This is a data center that actually has 3 racks of equipment. That honeycomb, every one of those is a node. So it shows the quick view of the state of the node. As you drill into the node, you'll get the details in terms of what's happening on that node. We, of course, have smart alerting that actually shows you node failures or disk failures and being able to, if you're looking at a rack of equipment, can I find which bit to replace, which bit's broken? We make it dead easy to actually do that. It's all fully automated. And then this is actually called a Sankey graph. This is how we view capacity. Again, you get the view of the total cluster, the breakout by data centers, and then the breakout by nodes. You get to see quickly anything that's going wrong in terms of capacity and efficiency across the cluster. Everything that we do here, you've got automated alerting built into the platform. So you've got SNMP traps if you want to set and just listen to alerts on SNMP traps. You've got email notifications, or of course you've got the visual interfaces. And then, yeah, I think I've touched on these, so I'm going to skip past these. Bucket level policies. Multi-tenancy to us means that your storage administrator has to have the ability to put controls on the system. Because there's different people. The end users in the groups know what their data is and how they want to manage it. But the system administrator understands how the system is configured, the networks, the connectivity, and the cost of his infrastructure. And what we have to do is give the ability for the system administrator to enforce that level of control across the environment so they can enforce the policies that are really related to how storage and data should be managed. And then allow the group or the tenant to be able to control their lifecycle policy, how much they want to age data, how much they want to tier to the cloud, what type of protection or level of quality do they need off their data. And so we separate that into storage policies where one-time storage administrators can set a set of policies. And to make this real, we're going to show it. That'll make it very real. And then storage administrators can then get to set their storage pools, allocate the bucket, the life cycle of the data that they need. And then QoS controls. We're going to show this later on, so I'm not going to jump into it now. Security is very key. So we look at security from 2 aspects. We look at it from the system down. So everything down to kind of the core system level. We do AES 256-bit encryption of all data. Down at the data level, as we read data, we checksum it. We do an MD5 hash checksum of every piece of data that we read. We validate that that data is correct. If we see anything that's going wrong, we automatically go and fix that data. So we're always checking and validating that data is correct. We do have versioning. So every object is versioned and every change is controlled and managed. And then up at the user side, full audit logging, very important for HIPAA compliance or for PCI-DSS and payment card industry compliance. You need to have the ability to audit all activities. You need to have the ability to also control users and RBACs and access control and have secure networks and TLS networks to connect into these services. So everything out on the user side is secure. Everything down at the data side is always validated, always correct. So one new thing that I want to mention, we just launched Hyperstore Connect for Files. This gives us not just the S3 interface now, but a full NFS and SMB Windows File Services interface direct into the object store. A couple of really important points. So there's nothing rocket science about building that, except all of the state is kept within the object store. It is completely re-entrant. If anything fails out there on that connector, we just restart it and all the state is always managed within the object store. And then the other piece that we've done is we've got this ability to do global locking and global versioning. We have an ability, we've got a view manager that can work across many of these gateways and stitch together one namespace view with locking and version control across that namespace. So quite unique, but very important to us was that you can't have state anywhere else except for within the state of the stateful storage, which is within the S3 storage layer that we provide.
How would you handle things like when, are you distributing those locks so that different stores will look after certain parts of the locks? So we don't. So right now we do have master slave on locking, and so what you do have to do is so it's not the most performant. This is for select data as you get into a distributed world. This is into a master slave locking, so you need to actually go and inquire off the owner of the lock at the time. Right.
And so it's really key that you manage that. Of course, when we're in the local data center only, all your locks are local, so this is only the ones that are really shared across data centers. And then compatibility guarantee. So everyone claims compatibility. Everyone says their stuff is S3 compliant. So I'm here to tell you they're not all S3 compliant. And this is testing that we just completed on Scality Ring, on an OpenStack Swift, Cloudian Hyperstore, and AWS. Now, the challenge with it, of course, is what's the benchmark you use? So we used a Ceph S3 benchmark, which is one that's built by the open source community. You'll see that's not a perfect benchmark because it says Amazon is 87% correct, which is a little daft. But what you're seeing is the benchmark is trying to keep up with Amazon as well. But what's interesting is if you assume this is correct, and this is Amazon's correctness, then you look at the most compatibility in terms of object storage relative to where Amazon is. And we're not quite at 100%, but we're 94.2% compatible. OpenStack Swift is 62.7%, and Scality is at 22.3%. So don't have a clever safe system. I would love to see you guys drive, how can we standardize this across companies? How can we do more open benchmarking on this? We're all on for it because we already have stated many times this is a de facto standard. It's time for us to actually get in there and let's open it up and let's use it like a de facto standard and let's do cross benchmarking on it.
So a couple of things I think that are unfortunate about that is that since I think you did that, the number of tests that are done through the software's been upgraded because it's just one guy, I think, making changes to it. It's already closer to 490 or a lot more. There's a lot more tests.
There's a lot more tests. Yeah, it's an ever-moving thing.
Yeah, so that doesn't help.
So yeah, it doesn't help. So I think the more that, this is a great, discussion, I think, for this evening, for this group of people. You're the right guys to kind of take something on like this. If we're seeing this stuff happen, then how do we standardize it? How do we prove it? How do you take vendors and say, call bullshit on it?
And I think the other thing as well, in your chart at the very beginning, you broke down ordinary features, advanced features, and so on. This doesn't give you any view of that.
Yes.
So you don't know whether the failures and the errors and skipped ones are anything to do with the basic features or the advanced, and that doesn't give you the ability to look at it and say, actually, I'm okay because all the basic features are being done. I'm not bothered about those advanced features, but then you might not have basic features being done.
I think that's a great point. So I think the point on this is, this is the beginning of, hey, we can do something in this space, we can prove it. But I think more work with you guys to actually go and really showcase, you know, how can we really make sure that everybody, you know, we bootstrap everybody in this and we build this as a better standard for everyone.
Can I say something about that? Because for many object storage vendors today, this is a request from the end user. The end user has an application, right? So you have to be S3 compatible with that application.
Mm-hmm.
So potentially, you said Scality is 22%. Yes, they are 100% compatible from the point of view of S3 for that application, because potentially they have 1 or 10 or whatever customer they have that are using that application, right? So in time, we will be 100%. All storage vendors will be 100%. Depends on the number of customers, depends on the number of use cases, and so on.
Yeah, potentially. I mean, I think there was a nice analogy to this. I think from our another person that I heard, which is, you know, we can look at SMB and Windows File Services. We look at that and we say, well, we got to have compatibility, and we bitch and moan if they're not compatible, because they're going to break something. I'm not able to do the extended SMB where I can actually do caching in the latest release, right? So you've got to look at these as standards that we must all comply to, because when we can, it opens up the application providers to not worry about things about whether it's going to work against one platform or the other. They know confidently it can work, and they can just use the value of the interface and the value of the API set. I mean, you wouldn't build NFS or SMBs that weren't compatible. We have the big effort around making everything compatible and hitting a level of standards compliance. We should do the same for object storage.